I'm Anil Kumar, and in this video, we'll try to understand what is direct relation. Now, whenever we say direct relation, we are actually looking at the relation between two variables. Let us say x is independent variable and y is dependent variable. Then these two variables have direct relation if the value of y, that means the dependent variable, changes as y changes in the same direction. So we say y is proportional to x. So we write the symbol, and this symbol here really means that y is proportional to x, right? Y is proportional to x. It really means that if x increases, y also increases. If x decreases, y decreases. So they are kind of proportional, right? And it's not only that y decreases, they increases by the same amount. So the important thing here is they increase and decrease, and the rate or the way they increase are in same proportion. This happens in same proportion. You get the idea. Therefore, we say y is proportional to x, right? So it is not just it increases, but it increases in the same proportion. That is to say, same times, right? Now, we could write this in the form of an equation also by saying y is equals to some constant times x, right? Some constant times x. So that is how we can relate the two. So this equation is actually the equation which relates direct relation. So direct relation, as you've understood here, could be written in the form of equation y equals to kx, right? Now let us see how to sketch this kind of an equation. So we'll make a couple of tables here and then write down different values of k and see how in a graph it is going to look like. So definitely it is a straight line. We can have some values of x and k. Let us say k is 2. Then 2 times x will be the value of y, twice the value of x. So if I write x as 0, 2 times 0 is 0. If I write x as 1, 2 times 1 will be 2. 2 will give me 4 and 3 will give me 6, right? Let us plot these values on a graph. So I'll create a graph here. Okay, so let's have a graph here. So what we are saying here is on the x-axis we'll show the independent variable. The dependent variable will be on the y-axis. Here it is the origin. And let's say this is 1, 2, 3, 4, 5, likewise, right? And here we have 1, 2, 3, 4, 5. So let's plot these points. So first one is 0, 0. The second one is 1, 2. So we get a point here. And then we have 2, 4, 2 and 4 kind of here. And then we have 3, 6, 3, and this one is 5. So it'll be kind of there, right? So let me just mark it, right? So 3, 6. You'll find that these lines, these points lie in a straight line. They lie in a straight line. So if I kind of join them, which I'm doing with the dotted line now, so they all lie in a straight line, right? So this relation is indeed a linear relation. So what we find here is that y equals to kx is a linear relation. And whenever you graph on coordinate planes, you'll get a straight line. Now, depending on what values x can take, we could have just dots, discrete kind of thing, or if x can be continuous, we could have a continuous line, depending on what values you put to x, right? For example, if let us say, let's take an example. let us say that we are walking at the rate of let us say 2 kilometers per hour, right? 2 kilometers per hour. Now time is continuous, right? Time is continuous. So in this case, if you want to make a graph between time and the walking distance, right? So if I write time here in hours, and if I say distance in kilometers is dependent on how much time we walk, at a constant speed of 2 kilometers per hour, in that case, let's say in 1 hour you'll cover 2 kilometers. Let's say this is 2 kilometers. So start from 0 time, 0 distance covered, right? So 1 hour, 2 kilometers, 2 hours, 4 kilometers. Since time is continuous, in such cases we normally join it, right? So we have a straight line like this. So keep walking and the distance increases proportional to the time walked. So you get a straight line, right? So it is important to note in any case whether the x values are few numbers, we say integers, or x value are real numbers, could be all values, right? Depending on that, we could get a straight point as a line graph, or we get a scatter plot. Do you see that? But important thing here is this relation will always include the origin 0 in it, since we know y equals to k times x. For x equals to 0, whatever is the value of k, y is going to be 0, because 0 times anything is going to be 0, right? So it is a straight line going through the origin. That is very important to understand. Now we could have a negative line also going through the origin, and that is kind of like this. Let me draw this line. Now, is that a direct relation or not? Let's look into this. Since I've seen sometimes students get confused about this, right? So let's have this line. So we have now, let me say this is kind of like this, okay? So at -1, the value is 1. At -2, the value is 2. So in this particular line which I've drawn, what is really happening is that as the x value is kind of, when you move left side, you say decreasing, correct? So let me make a table for this one, and we'll understand that also. So what is happening in this case is, let's say we start with 0. Okay, let's start with 0, and let's go in this direction, -1. So we are decreasing, right? So the y value is 1. If we go to -2, y value is 2. And if I take a value here, at 1, we get -1. So at 1, we get -1. And at 2, we get a point which is at -2. So at 2, we get -2. So these are my x values. How are they related with y values? Can you find a relation? Well, very clearly, it is -x, right? So in this case, the constant k is equals to -1. Do you see that? So k, this constant, could have a positive or a negative value. In case k has a negative value, in that case, you will find that the line is dropping, but it goes through the origin. This is very important. So what we realize here, let me summarize that a direct relation will show a graph which is linear and which will include the origin. That is very important. And as far as the equation is concerned, we can write this equation as y equals to k times x, where k is a constant. K could be any real number. It could be positive, negative, fraction, whatever. And this relation, y equals to k times x, could also be written as ratio y over x equals to constant, right? So when I write this as k over x equals to a constant, we say this is kind of proportional, right? These are same ratios. So that is how every proportions, when we talk about, they are in direct relation, right? So y over x is a constant for a direct relation. So these are important things to remember when we talk about direct relations. And speed, distance, time, if the speed is higher, we can cover what if distance, I mean with time. In speed, distance, time, let me write down the relation here. Speed, distance, time, which we took here as an example, we could write distance as equal to product of speed and time, right? So in this case, that is an application. Let me squeeze that application here. So in an application, example, distance is equals to speed times time. What we find is that speed is constant or proportionality. So for a constant speed, only for a constant speed, this relation is going to be a direct relation. This is important to understand. So if the speed is constant, then distance equals to speed into time will represent a direct relation. Is that clear to you, right? If speed is not constant, then this will not be a direct relation. That is very important to understand. I'm Anil Kumar, and I hope that gives you some idea about direct relation. We'll look into some questions and elaborate on it. You can always share and subscribe my videos. Thank you and all the best.